Hiya, Year 10, it's Mr. Green here. I'm going to take you through the second lesson of the energy topic, which is the first one of the physics, and our lesson objectives today to know what happens when the energy in stores shifts to a new store. I'm going to start, as always, pause the video and take that learning objective down as your title. Okay, you're going to start as always with retrieval practice. Just pause the video while you answer these 5 questions and restart it when you want the answers. Okay, so question 1, name 2 energy stores. Well, there's 8 to choose from. Any 2 of these would be fine. Kinetic, magnetic, internal, chemical, electrostatic, elastic potential, gravitational potential, and nuclear. Question 2, name 2 energy transfer pathways. Well, there's 4 to choose from, so any 2 of these would have been fine. Mechanical, thermal, electrical, and radiation. Question 3, can energy be created and destroyed? Only answer to that one is no. It can only be transferred from one store into another. Question 4, what's the definition of energy? Energy is the ability to do work. So what does that definition mean? Well, simply that definition means it allows matter to move or it causes change. Basically, energy makes things happen. Okay, focus of today's lesson is to identify the main energy pathways and to explain how energy is shifted from one store to another by the energy pathways. Start off with our energy systems. Bit of revision from last lesson. If we had a bungee jump that was in a closed system with no air resistance, what would happen? Well, there's no net change in energy there. There's no energy leaving or going into the system. So the bungee jumper would jump, go down to their full extension, and then start to come back up. But they would come back to their original height where they jumped from. Then go down, back to the lowest point, back up to their original height, and continue doing up and down for eternity. In an open system, that would change. Some energy would be transferred to the core. That would cause it to heat up while it's being stretched. That transfers energy to the surroundings. So each time he bounces up, he wouldn't go as far as his original height. Every time again he bounces up, it'd be further and further down until he eventually comes to a stop. This is conservation of energy. So our 4 energy pathways, which we studied last lesson, I'm just going to go through them again because it could be useful as we get to our flow diagrams here. So 4 pathways are mechanical, when a force moves through a distance, electrical, when a charge moves through a potential difference, thermal, because of a temperature difference, and radiation, which are things like light, microwaves, and sound. These are ways energy can travel. Energy can move from one store into another. Mechanical, there's an example, lifting a block of wood from a floor to a shelf. If we start at the block on the floor and the end point is the block on the shelf, I've had to use energy from my muscles. So the chemical energy store in my muscles has gone down. The log's been lifted, so its gravitational store has increased, and that was a mechanical pathway. In a thermal pathway, the starting point and the end point are the same. It's the fire in this case. The chemical store in the wood has gone down while it's been lit, and that's increased the internal store of the wood itself and the fire. This has been filled by the thermal pathway because there's a temperature difference. An electrical pathway. So for example, a lit torch. Start and end point is the same as the torch being lit, but how does it maintain or stay lit? Because the chemical energy in the battery or the chemical store in the battery has gone down, and the internal store of the wire has been filled. And that's via the electrical pathway. Finally, the radiation pathway. Go back to our fire. Start and end point is the fire again. Chemical store in the wood has depleted, and the internal store has been filled via the radiation pathway. So, different from the second one where it was filled by the thermal pathway, this one by the radiation, producing light. When we describe energy with energy stories, they should all have the same layout. Start point, end point, and then which store is depleted, which store is filled, and the pathway. There could be multiple stores filled. Now when we're doing energy transfer, we can draw diagrams, so flow diagrams to show the energy changes that occur. So first we've got to consider changes to the energy stores and how the energy is transferred. So the example we've got here is a car braking. We start off with kinetic energy. So the car's kinetic energy store is full because the car is moving. There's then a mechanical energy transfer. And that turns into sound waves, an increase in the thermal energy store of the brakes. The kinetic energy store has decreased, but where's that energy gone? Energy can't be created or destroyed. So the sound waves are produced, which is kinetic energy, movement of particles, and the thermal energy store of the brakes has increased. And this has all been from a mechanical energy transfer, from the brake pads forcing themselves onto the wheel. Let's have a look at another one. So changes in energy stores in a torch. So when a torch is lit, what happens? Well, we start with chemical energy in the batteries. That transfers to energy transferred to the surroundings. By what form? We've got light waves, and we've got an increase in the internal energy stores of the surroundings. So all the chemical energy is depleted, or it is depleting. As that's depleting, the increase in the internal energy stores of the surroundings is going up. Light waves is going up by the same amount. What are the pathways on these? Chemical energy to the surroundings is an electrical pathway through the wires. The surroundings then from a radiation pathway to go the light waves, and the thermal pathway to increase the internal energy stores. The light waves eventually go to heating the surroundings, so that would be a thermal pathway again. How about an object falling and hitting the ground? We start with gravitational potential energy because it's high above the ground. As it's falling, that changes to kinetic energy because it's moving. As it hits the ground, transfers energy to the surroundings with sound waves and with an increase in the thermal energy stores of the surroundings. Again, heat produced. What are the pathways though? We've got mechanical for the first one. It's a force moving through a distance. Mechanical again because we've got a force hitting in the ground. Radiation for the sound waves. Any waves are a radiation pathway. And thermal for the final one, there's a temperature difference. So the key facts on these are, energy can be stored in different forms in different objects. When one store increases, another must always decrease. When an action takes place, the energy store reduces, the store for thermal energy always increases, and sometimes kinetic energy. After the action, thermal energy is always increased. Sometimes the radiation energy store also increases. Let's have a look at a way of representing this. So, we've got Hermione using a certain spell on her feather. While it's in the air, it's got a gravitational potential energy of 100 joules. So we've got there 10 blocks of 10 joules as its gravitational potential energy store. Now, as the feather moves downwards, the gravitational potential energy store reduces. Because the feather's moving, kinetic energy store is increased. The thermal energy store also increases due to friction in the air. Now, if we look, the gravitational potential energy has gone down. It was 100, it's now 50. So how much has been transferred to thermal and kinetic? Conservation of energy tells us 100 has been converted to that. When we look at kinetic, we can see that 30 joules have gone to kinetic energy. So how much must have gone to thermal energy? We know it's got to be 100 in total because energy is conserved, so it would be 20 as thermal energy. Feather lands on the table and has these energy stores. Pause the video and explain why it has those values. Okay, it has zero kinetic energy because it's not moving anymore. Gravitational potential has gone down to 40, but because of the friction that's occurred, because it's moved through an area but now it's not moving, all that energy has now gone into internal energy in the feather. So total internal energy in the feather is 60, gravitational potential is 40, in total we have 100 joules. Okay, let's have a look at some examples. What are the energy shifts in these cases? We've got a pot of water, so a pot that's boiling on a fire. What are the useful energy transfers? What's the wasted energy transfers? So if we look at this diagram, this shows us we have these energy stores. We've got chemical, thermal of the wood, and thermal of the pot. Chemical is completely full, thermal of the wood and the pot are quite low before it's heated. After, chemical's gone down. It's gone down by 5. So what must happen to thermal in the wood and thermal in the pot? They must both increase by a total of 5 between them. If the thermal in the wood has gone up by 2, how much must the thermal in the pot have gone up by? Gone up by 3. So in total, again, it's the same before and after. Okay, so for a car moving from rest, what are the energy shifts? So before the car starts moving, it's got a large energy store in its chemical energy in the petrol. Kinetics is 0 and thermal is 1. It's got some internal energy. Once it starts moving, chemical energy drops by 5. So the kinetic and thermal must raise by 5 in total. Kinetic goes up by 4, which means the thermal goes up by 1. in total making 5. What are the energy shifts when a flower's photosynthesizing? Well, we get nuclear energy from the sun. The flower's got some thermal energy and some chemical. Again, once it started, nuclear energy, let's say that's gone down by 6. That means thermal and chemical must go up by 6 in total. If the thermal's gone up by 2, what must the chemical go up by? Goes up by 4. So again, total energy is always the same before and after. And with a hydroelectric power station, we start off with gravitational energy at the top there, really, really high. No electromagnetic and no thermal. Once we start it, the gravitational drops by 6. Electromagnetic goes up by 5, which means the thermal must go up by 1. Total energy is the same. So, pause the video while you answer these 2 questions. Restart them when you want the answers. Okay, question 1. Energy changes to energy stores when a ball falls in the air. So when a ball falls in the air, we get gravitational potential emptying and kinetic energy filling through a mechanical pathway. Again, those energy changes will be the same. As much as gravitational goes down, kinetic will go up. For an electric heater that's switched on, chemical energy empties and the internal fills. Remember, we get our energy from power stations, which generally will use coal, oil or gas. That's a chemical energy store. The internal fills, and that's through an electrical pathway because it's an electric heater. 2 objects you could use to provide light and detail the energy transfers and energy stores for each. So we could use number 1, a torch. Chemical in the battery goes down, kinetic energy particles around increase through an electrical and radiation pathway, the radiation producing the light. With a fire, the chemical in the wood depletes and kinetic energy, internal energy particles would increase by a thermal, then a radiation pathway, again producing that light. Quick exam question. Complete the sentences about the bungee jumper. Pause the video whilst you try that. Okay, so before the person jumps off the ledge, he has a store of gravitational potential, very, very high. As the person falls, there is a store of kinetic energy that increases. As the bungee cord stretches, it stores energy as elastic potential. Second exam question. Look at this one about a campfire. Pause the video whilst you attempt it. Okay, the wooden logs are a store of chemical potential energy. When the wood's being burnt, this increases the internal or thermal energy store of the surroundings, and energy is transferred between these stores by waves, and that would be a radiation pathway. Okay, so multiple choice questions to finish. Pause the video whilst you attempt these, and I'll go through the answers just after. Okay, question 1. Which of the following is an energy pathway? Kinetic, chemical or electrical? Electrical only, the other 2 are stores of energy. Which of the following is a form of radiation pathway? Number 2. Light, kinetic or gravitational potential? Again, 2 of those are energy stores. That would be kinetic and gravitational. Light is a radiation pathway. Question 3. What's meant by a closed system? Is it energy moving in and out, energy only moving in, or the total energy remaining the same? Correct answer would be C. The total energy remains the same in a closed system. In a closed system with no friction, what happens to all the gravitational energy of a falling object? Is it wasted? Does it shift to kinetic? Or does it change to heat? Correct answer is it all shifts to kinetic. Again, with a closed system, no friction means that you're going to get no heat produced. Question 5. What form of energy store is in a stretched rubber band? Chemical, elastic or magnetic? If it's stretched, that would be elastic potential. Thanks very much for listening to that. Please review the video again if you need to clarify anything. Hope it was useful. Thanks a lot. Goodbye.